This video will show you how to use the vapor generator on the AutoChem 3. Remember to always consult your operator's manual for more detailed information. Care should be taken in selecting vapors. Corrosive gases will damage the instrument. Make sure to contact your Micromeritics representative to verify the selected vapor will not damage the instrument. Fill the Erlenmeyer flask to approximately 50 milliliters with the vapor source liquid. Hazardous vapors should be prepared under a fume hood. If a hazardous vapor is used, submerge the flask in an ice bath for 10 minutes to lower the vapor pressure before removing the cap. Attach the flask to the instrument here. Wrap the heating mantle around the flask and secure with the strap and zipper. An appropriate reflux temperature can be calculated by using the Antoine equation to generate a vapor pressure of 0.1 to 0.2 bar, which translates to 10 to 20% vapor composition by Dalton's equation for partial pressures. The temperature of the flask should be 5 to 10 degrees above the temperature of the reflux, but should remain below the boiling point of the liquid. To learn more, see Application Note 134. Create a new sample file and navigate to the Analysis Conditions tab. To choose a vapor, click Insert and Experiment. Select the vapor checkbox and the desired vapor from the drop-down box. To get a vapor flowing through the system, click Insert and Instrument Settings. Select helium with a flow rate of 25 cubic centimeters standard temperature and pressure per minute for the carrier, reference, and loop gas. Select Vapor for the vapor flow path and uncheck Disable Vapor Heating. Enter the flask and reflux temperatures for the specific vapor. At this point, the vapor can be pulsed onto the sample or can be used to saturate the sample with the blend valve. To see how to create a sample file, please view our How to Customize a Sample File video. Ensure that the heating mantle is disabled and has returned to room temperature before beginning. Remove the heating mantle and the flask containing the previous analysis vapor. The flow path must be cleaned in between different vapors. Insert a new empty flask. In the MicroActive software, click Unit and select Enable Manual Control. Double-click on Loop Valve to enable the helium gas. Double-click on the Mass Flow Controller, set the flow rate to 25 SCCM. Double-click on the Vapor Source Valve and wait for 30 minutes. Then, turn off the helium gas valve, close the Mass Flow Controller, and double-click to bypass the vapor source. Insert a new flask with isopropyl alcohol and reattach the heating mantle. Under the Unit menu, select Show Instrument Schematic and enable manual control. Set the mass flow controller to a flow rate of 25 standard cubic centimeters per minute. Double-click the helium valve to have the gas flow through the vapor source. Bypass the blend valve and fill the loop valve. Allow the gas to flow for 30 minutes. After the system has been cleaned, double-click to turn off the helium gas, close the mass flow controller, and bypass the vapor source. A vapor calibration can be performed in order to quantify the vapor within the system by generating different vapor pressures. Under the Analysis Conditions tab within a sample file, click Insert. The two vapor calibrations are flow and pulse. A vapor flow calibration should be selected if the blend valve is used during an analysis. The vapor pulse calibration should be selected if the loop will be used and the vapor will be pulsed. After making a selection, select the carrier and loop gas and the flow rates for each. The gas and flow rate must match what will be used during analysis. Choose the vapor from the drop-down box and enter the minimum and maximum temperatures for both the reflux and flask and the number of steps. The steps define the increment between the minimum and maximum temperatures. Check Set External Trigger if the MS signal is collected for the calibration. Otherwise, turn this off. This video demonstrated how to use the vapor generator on the Micromeritics AutoChem 3 automated catalyst characterization system. For more information, visit micromeritics.com/learn.